Right. Well, I have a couple of different things to talk about today. I suppose I'm bringing an engineer's perspective on some of the problems of sustainability. And what I'd like to do is talk firstly about the Mistra Future Fashion program, what it is, talk a little bit about how we're approaching transparency within the project, some thoughts about Higgs, and some of the preliminary results from our program. So what is this Mistra thing? Well, if you hadn't heard of Mistra, it's the Swedish Foundation for Strategic Environmental Research. What that means in practice is it's a big bucket of government money with some clever people giving it out to worthy research causes around the country. And perhaps about 5 years ago, a couple of those people decided that there was a lack of good research going on in the area of improving the sustainability of the fashion industry. And so they decided to run a competition for 40 million crowns of that money over 4 years. And I was part of the consortium that was successful in winning that support. So you see there in the left two panels the research institutions, mostly universities and some research institutions that represent a range of Scandinavian talent. We also have the University of the Arts London, who are our, let's call them academic researchers and practicing fashion designers at the same time. So we have a wide range of skills within the consortium. We have a larger number of participating companies who are also partners in the project, and you see them in the right-hand panel there. So they represent all sorts of elements in the potential future supply chains, from, let's say, forest-based cellulosic textiles through to what happens to the waste from the fashion and garment industries. So it's a broad slate there. We're aiming to have phase 2 starting in the not too distant future, and the exact makeup of those industry partners could change somewhat, and if that's a project that you're interested in participating in, then I think we'd welcome hearing from you. So get in touch. Now, the program is quite broad. We don't think any one particular solution is going to turn around the garment industry, is going to be the silver bullet that creates systemic change. We need to address the issues and activities from many different possible perspectives. So one thing is to address the way that the commercial aspect of the fashion industry operates. Are there different ways of organizing our businesses that are profitable but are more sustainable in some way? We feel that the fashion designer could use assistance in getting better and more useful information when he or she is designing a new garment. We don't think that there's enough and useful enough information out there, so we're trying to address that. Of course, the consumer is king, and the consumer controls to some extent where the industry heads using the consumer's cash. So if we can change consumer behavior, that has potential to create systemic change also. Government plays a big role, particularly in the parts of the supply chain that the textile industry and the fashion industry do not directly control. I'm thinking about waste management primarily, but there are other elements of the life cycle of a garment where the government and other regulatory institutions can play a significant role. So we've got policy instruments there too. And last, but certainly by no means least, there are some technological solutions. We don't think technology is going to solve all of the challenges that we face, but it may certainly make it easier to solve some of them. So we have a technological focus as well. There are many different disciplines represented in the program. I'm not going to go through all of these 8 dots, but just to say that the program is divided up into 8 different projects, which is, each project is, if you like, a sort of a kraftsamling, a critical mass of researchers drawn from those different institutions to work together. So for example, in the project that I manage, Project 2, which is about clarifying sustainable fashion, we have researchers from SP and from Sverige and of course from Chalmers University of Technology who are working together in a common cause. But there's all sorts of other people in this constellation here. We've got political scientists, we've got behavioral economists, all sorts of interesting job titles, in fact. Now, these disciplines obviously need to work together in order to generate lasting solutions. And so, for example, the top left constellation there, if we want to have better chemical recycling of cellulosic materials, it's not just a matter of getting together with our cellulose chemists and our material scientists in Project 5, for example, but also talking to our behavioral economists in Project 7 to try and work out how can we get a more purified cellulose recycle stream back to the factory. One of the key barriers to, let's say, fibre-to-fibre recycling is the fact that we often have to deal with very mixed up recyclates coming back to be dissolved in some kind of chemical process. So if we can influence both what happens, let's say, through in-store recycling to get a better kind of raw material, and also then adjust our processes in the laboratory, we've got a better chance of succeeding. So I'm not going to go through all of those constellations, but just to give you the sense that there are some strong disciplines within the program, and there are also some strong cross-disciplinary activities. I'd encourage you to go to the website if you'd like to learn more about the program. Have a look at our annual report, which describes all of this in a lot more detail than I can do in 10 minutes. Now, what about transparent communication? Permit, if you will, a little personal anecdote. When I was 7 years old, I lived on a street where there was another 7-year-old boy a few doors down the street, a guy called Nick, and we used to get into all those sorts of healthy activities that you expect of small boys, riding bicycles, throwing rocks at beehives, and bragging. And I remember one particular bragging session where Nick claimed that his father's car was better than my father's. Now, this perhaps was true. His father owned a sports car. Mine had a Ford family wagon. But nevertheless, he opened with, my daddy's car is faster than yours. And I said, oh yeah. He says, yeah, it can do 260 kilometers per hour. I said, 260? I mean, that sounded a bit ridiculous, even if, you know, I don't think a car would stay on an Australian road at 260 kilometers per hour. But anyway, he said this, and I said, well, how do you know? And he said, well, it's on the speedo. Proof. Of course, at this point, he'd won the debate, because my daddy's car only went up to 240. Now, what's this got to do with transparent communication? Yes, well, let's think about what Nick was saying here. On the one hand, he was being transparent. You know, he had an honestly held opinion. He said what it was. He described it quantitatively. He explained his reasoning, and he even gave his source. What's not to like about that? But if I'd been a better debater as a 7-year-old, I might have said, well, just because you've got a management system that will indicate if your car is traveling at 260 kilometers per hour, it doesn't mean it's actually ever reached that speed. And I think that's relevant when we talk about communicating sustainability in the clothing industry, because very often we may be focusing on the wrong thing. I think in a perfect world, transparent communication about sustainability would be based on the things we want to change. We want to reduce the water intensity of our garments. We want to reduce the carbon dioxide emitted by the fact of buying and using a shirt. So these are the important things, really. And We need a lot of different indicators to help us on our way, but we can't get away from trying to communicate about the things that we need to change. There are other things that would happen in a perfect world. The data acquisition and processing to do this kind of communication would be cheap. All the relevant systems and issues would be covered, and the assessment will be based on appropriate geographic and technical specifications. So there's a wish list. I want to explain a little bit more what I mean by those last 2 points, one slide each. Now, I've been very happy to see the last 2 presentations from Baptiste and Imola, because they've really said the same thing as this slide, that if we want to cover all of the environmental issues, we need to think about several different issues within, let's say, the strictly environmental aspects. It might be climate change, it might be the effects of toxic chemicals. They're all relevant. We need to also think about the social impacts in an industry that's as labour intensive as the textile and clothing industry. And of course there's resource impacts as well. Water was brought up earlier. Some resources that are renewable are under incredible stress, and some resources that are not renewable we wish to use less of. So there's, let's say, a broad spectrum of issues that we need to encompass. We need also to adopt a life cycle perspective of the systems that are using those resources or making those impacts, that doesn't just focus on the factory where they're built or just the use phase, but what's happening at the end of life, for example, or the transportation elements. So this is what you could call a life cycle perspective, and it's embodied in the ideas referred to by the previous speaker of a product environmental footprint. Now, what do I mean by appropriate geographic and technical specifications? The picture's slidden up a little bit, I'm afraid. Anyway, those specifications aren't going to be the same for every study you do. And this is one of the points I want to make. Exactly what data you need depends very much on what sort of question you're really asking. So, for example, in this graph here, which is just some data I invented for this slide, you have the performance, the environmental performance of shirt manufacturing at different scales of geographical relevance. And you can see there that if you're taking the global, let's say the global mode of that data would be 10, the mode of country Y's would be 15, and Mr. X's factory's got 17 on that scale, whatever the scale is about, carbon dioxide or water, you choose your favorite. Okay, so if I'm going to communicate the environmental impact of that product, let's say that shirt, I have to be a little careful here. If I'm trying to describe the global challenges of the textile, the clothing industry, I have to, it's no good if I refer just to the data from Mr. X's factory. That data is so specific that it's meaningless to answer the question at hand. And the opposite is also true. If I want to put a label on the shirt in my boutique, it's no good me using some kind of global mean or median or modal data because it's not relevant content for that particular shirt. So there's some challenges here about what kind of basic data we use. We've also got challenges in how we then interpret it. For example, if we've got knowledge about the actual mass of chemicals being emitted at in different parts of the supply chain, we need to know whether those things actually have an impact. And assessing chemical impacts is hard. In a classical quantitative chemical risk assessment approach, you would need to build a model of all the possible ways in which people or the environment could be exposed to those chemicals. Now, this is a diagram that I've ripped from one of our papers, which was really just focused on the sewage side. And you can imagine, of course, if you're dealing with a long supply chain with all sorts of dyeing and harvesting processes upstream, you name it, this would be a much, much bigger diagram and basically impossible to use. Too complicated. So we don't use it. We have to compromise and use something a little bit simpler. And this is a picture of one of the main models of interest today, in assessing life cycle impacts of chemical emissions called use tox. And you can see there those little arrows going between boxes. These are all things, flows that need to be estimated in order to say, if I emit a certain amount of chemical somewhere here in a city, how much impact will it have over there in an ocean? So this is a consensus model that is being worked on at the moment. And that offers some promise for this sort of work. But at this point, only about 4,000 or 5,000 chemicals have been characterized using use tox. And in the marketplace today, there are at least 80,000. So there's a long way to go. So communicating about sustainability in the real world is very difficult. We've got problems with data being confidential or simply non-existent. Nobody's measured that number yet. We've got the problem that in a supply chain leading to your boutique, there may be all sorts of contractors who may change from year to year. And if you're trying to look forwards, if you're the designer looking at a possible future product, you don't necessarily know where things are going to be sourced. And then, as my last slide hinted about, sustainability can be very complex, and many customers want simple messages. I liked in our last presentation that display of many different ways of possibly communicating sustainability. I think we need to try them all. Yes, there are people who just want to see a single tick on a tag, and then there's other people, perhaps like many of us in the room, who won't be satisfied by that and need to be able to burrow in to find greater detail. Now, when we think about that then, it's very interesting learning about how the Higgs Index is working. The Higgs Index is one of the most interesting initiatives because so much work's being done under that umbrella and so much information is being published. At the moment, there are 3 levels on which the Higgs Index tools work: the facility, the product, and the brand level. And as Baptiste indicated, there are perhaps ambitions to try and combine these at some point and ambitions to try and create a customer-facing tool. But at the moment, it's not that. It's about communicating within businesses or between businesses. And I've put a dark line around the first box there on the screen and just dashed ones around the other ones because the kind of data that's being used for each of them is a little bit different. So for example, when we're talking about facilities, a lot of the data has to do with whether or not you're tracking energy use. You get points for having an idea, or you get points for being able to put a number to the energy consumption you use, irrespective of how big that energy consumption is. And having targets for it is also something you get points for. Same thing with the brand. You have some qualitative questions. Is there a restricted substances list? If there is, that's a good thing. Are the public able to see it? You get more points for that. Is there a goal in relation to that? Even more points. So these are, if you like, useful indicators of whether or not the companies involved in this process are able to find their way forward, whether they have made some important initiatives on that way. It's, if you like, a qualitative assessment of the performance of the facility or the brand, in these cases, using a multi-criteria analytical process. I'll look a little bit, just one slide on the product side there, what those letters are. As you should remember from Baptiste's show, that's MSI's Material Sustainability Index. And that's a really nice, place to go surfing, okay? The Material Sustainability Index is, it must be $1 million website. There's all sorts of information you can find and lots of detail for the data hungry like me. So it's very nice how open and transparent that particular thing is. Now the MSI data is built into a bigger beast called the Rapid Design Module Beta, and you can see there that there are various other elements of it which attempt to look at the other parts of the product life cycle. So we have some qualitative questions, for example, around packaging. Do we have some kind of packaging strategy? You can get 5% for that. And then we have those quantitative parts, which are in the first bit there, the 15% from the MSI, where it is actually in terms of impact per kilo of product, rather than some kind of grouping of material finishes or a grouping of treatment processes. So let me not sound too harsh about Higgs. I'm very excited that this idea of applying a life cycle perspective to clothing has reached such a mature phase of development, and that Higgs and the SAC are being so incredibly open and honest about what they're doing. The fact that I can go online and dig up this kind of information and think about it is a real tribute to the transparency going on there. No, what I want to do by bringing up this is really address some other people. Nothing I've got here is news to the SAC, but I sometimes hear in academia and industry the view that, oh, we don't need to think anymore about our sustainability work. We've got the Higgs Index. It's already solved. But if you go onto the Higgs website or you listen to Baptiste, you'll hear that there are a whole lot of things that are still in the pipeline and things that need to be done. And it's not surprising when you consider where we are in terms of life cycle assessment of the clothing industry. Life cycle assessment as an idea has been growing exponentially. This is a log scale you see on the right there. So it's been growing exponentially for over 20 years in terms of the amount of work being published in this field. And don't imagine that this is something that just academics sit at home doing, writing life cycle assessments. We can't do that without industry collaboration. And so very early on we had real strong interest from the water industry, from basic chemicals, from the building and construction industry, and life cycle assessment has grown continuously over those preceding 20 years shown here on this graph. The food and agricultural industries got into it relatively lately because they, I guess, have open systems. They're difficult to model, those sorts of things. The clothing industry is the most recent to start growing in this exponential way. And I think that if you look at this data as at least some sort of proxy indicator of the amount of work that the clothing industry has been put into this, it's very promising, but it started a lot later than other people. And that's why it's not so surprising then that the part of this rapid design module that is the most quantitative refers to raw materials that other parts of other industries, other sectors and academia have been studying a lot earlier. I think this promises that we'll be able to get a lot more quantitative data in the future. A little bit of that data is coming from Mr. Future Fashion at this time. I wanted to just give you a little teaser about some of the work we're doing. This data is preliminary, so I'd appreciate it if you don't cite it as, cut in stone, as we say in Swedish. But what we decided to do was to try and get an overview of the impacts of 5 important garments in the Swedish context. A t-shirt, a pair of jeans, a dress, a hospital gown, and also a bomber jacket. So we're doing some very detailed life cycle assessment work on these 5 garments and looking, as you can see there, at a wide range of traditional life cycle indicators. And we can divide the results up according to whether the damage is occurring in the fabric and garment production phase or in the use phase or wherever it may be. So this kind of information gives us clues about where the most improvement in potential lies for the clothing industry. We can also drill down into this at much greater detail and see where those impacts are. And for example, here we see that for the carbon footprint of the t-shirt, that the fabric manufacturing stage is relatively important. One of the things that surprised us here was how important the consumer transport part is. That is to say, getting the product from the shop to the home, or at least getting the customer to the shop and then returning with the product. We didn't see a lot of, I don't think we found any studies that really included that element of the product life cycle previously. So we thought it would be interesting to do that. And even taking some fairly, I'd say some fairly conservative assumptions about how the consumer gets there, including a bunch of public transport, we end up with a fairly significant component in the overall life cycle. But as I say, this is preliminary data. It's going to change, no doubt, when we produce the final report, which I hope you'll all be able to read next year. And in keeping with our commitment to being transparent and open about all this, it's a report that it's currently about 100 pages long. Half of the pages are data tables and references, because we think that other people should be able to follow things up and check our assumptions. So if I can just leave you with a couple of aspirational transparency goals. For academics, transparency is about citing your references. It's about being able to find out how something was decided or calculated. It also means talking about the quantitative product or organizational performance rather than just whether that organization had a management system. It means having better coverage of the issues and better coverage of the technical system than we have previously seen. And it means fitting the degree of generality of the data to the particular type of question you're asking. And I'm going to leave you with one of my favorite inspirational, I would say semi-religious quotes here from a fellow called Kenneth Boulding, who said that somewhere between the specific that has no meaning and the general that has no content, there must be, for each purpose and at each level of abstraction, an optimum degree of generality. And here are my references.